Welcome aspiring data scientists and welcome future Python programmers. Today we have a second lecture about the open library Pandas. In the previous class we learned what is actually a data frame. Then we did some subsetting of the data frames, and during the lecture we also learned how we can import a CSV file into our Jupyter notebook or into our Python program. The content of today is more working with Pandas data frames, but this time we learn two very important methods to subset, and these are the loc method and the iloc method. So let's remember the slide from last lecture actually. First, at number 1, we import our CSV file and put it into a data frame. We store it in countries_2. We read the CSV file by using pd.read_CSV. And then we have to remember a new index was here created. If we want to substitute basically that index with new words inside or new values inside, we could say now, okay, to our countries_2 variable or data frame, we apply the .index method. And we want to store as our row labels or index labels, we want to have DE, NL, and UK, and FR. So more descriptive names as our row labels. So now we do loc-based subsetting or label-based subsetting. Why is it called label-based? Because you basically always write the label into your squared brackets that you want to search for. So we can either search for our row labels or we can search here on top for our column labels. And in this example, first we search for an array again, for a series, and we do this again by first using our data frame. Then we apply the loc function to it, and after that we define the row that we actually want to print out. And in this case, it would be the index of FR. So we get all values associated with our index FR. If we want to print out a data frame, and normally you should always print out a data frame if you work with Pandas, we have to use the double squared brackets and we apply again the loc function to get one data frame which contains the index FR, our column labels, and obviously all our values. If we want to select now through loc multiple columns or multiple elements, we can do this too. First, you can see in the blue and the green example, we first apply the loc function again, and then we want to subset for each row. In this case, it's DE, NL, and FR. And if we look at the data frame at our output, we can see that all values are included, including DE, NL, FR, and all column values are included again. So we can also subset for columns and rows. So in the red box example, we first subset for those 3 rows, and after that we only subset for these 2 columns. And if we print out our data frame, we can see that only our 3 indexes are given and only our 2 columns are given, and of course the associated values with those rows and columns. Now we can do the same example from last slide. So we want to search for DE, NL, and FR, and we want to find the values for those 2 columns. If we want to approach it a little differently and we want to print out all rows, but only specifically the columns GDP and population, we can just use for our first square brackets, we can just put the double point. And as we already know, the double point means just that all rows are getting printed out because we don't define a beginning or ending here. So if you use the loc function and you leave the first part empty and just use the double points, and after that you define your columns, you can see that the whole all the rows are getting is our output, but only the values from the 2 columns GDP and population will be part of our output. So overall, we can say that log is very useful if you know already the labels for your columns and for your rows, and you want to subset for those. So sometimes you maybe don't really know the values that are stored in your row index or in your column index. And for that case, you cannot make a label-based search, but more a position-based search. So we basically access the index numbers again. So each column has their own index number and each row has their own index number. So in this example, if we look at our green box over here, we use iloc, so position-based, and we only want to have the row, which is in this case the third row, so index number 2. So we get again all values for the UK. We can also do multiple rows, and in this case we do actually the same example as we do with the log method. In this case we just substitute it with iloc and we choose our 3 different index rows that we actually want to print out, and in the end we print them out. And as you can see, it is exactly the same result as we did with our log function. If you now want to print out column and rows, you can obviously do that also with iloc. And in this case, again, first we define the index rows that we want to print out, and after that we define the column indexes. So in this case, we want to have 3 different rows, 0, 1, and 3, and we want to have 2 different columns, and in this case they have index number 2 and 3. So again, we do the same thing as we did with log, only through a position-based search or subsetting. And here you have the same example again. If you want to have all rows, but only specific columns, you can leave the first part empty or only with double points, and in the second square brackets, you actually define which columns you would like to have. In the end, we have a quick look at our data structures. Overall, we could say that for simple data structures with different data types, we should normally use lists. If it gets a little bit more complicated or a little bit more nested, we could say, we should normally stick to using a dictionary. But you will get a little bit used to it and you will develop your own feeling when to use what. So the more and more complex our data becomes or our data sets become, we should stick to using either NumPy or Pandas. And probably in the end, the majority of the time, you will use Pandas because we will work with bigger and bigger data sets. In short, we can say primitive data structures. I didn't come up with that name, someone else did, so we just stick to it. For now, we can say these are, for example, integers, floats, and strings. And for non-primitive data structures, so let's just say more complex data structures, we can say we have learned so far lists, dictionaries, and array. And in arrays, we can have a singular array, a 2D NumPy array, or even a data frame. And the big difference with lists is you can store different data types inside of it, but you cannot really make any good calculations with it. So lists are good for storing different data types. Dictionaries are, on the other hand, is useful if you have a little bit more complex structure and you want to have like one important key and then sub-keys. And in the end, if you really want to go in depth, you want to make calculation, you want to make manipulation of your data sets, then you should stick to NumPy, or even better, you should stick to Pandas because you can do a lot of different calculations through them and you can also modify your data sets. So the learning goals we have achieved for Pandas, a very, very important part of our online lecture is working with Pandas DataFrames. We imported our first CSV file, but we learned more about that later too. Then we did subsetting of data frames, and then we also learned the 2 important log and iloc methods to actually subset on either label-based or position-based in our data frames. Congratulations, you finished another online lecture. Please don't forget to make your Jupyter Notebook assignments, and we're looking forward to see you in the next video. Goodbye.